In this video, we look at using a spreadsheet to display a binomial distribution. So we'll look at an example. There's a 70% chance that an allergy drug is effective on a person suffering from the symptoms that the drug treats. We're going to create a table and a graph showing the probability distribution for 10 people. Now recall, this is a binomial distribution. With a binomial distribution, we have identical independent trials. And we're either looking for a success or a failure. So either the drug works or it doesn't work. That's what makes this a binomial distribution. Here's the formula for a binomial distribution. So the probability that the random variable x is equal to an element in that random variable is equal to n choose r times p to the r times q to the n minus r. Now in this equation, n is the number of trials, r is the number of successes, p is the probability of success, and q is the probability of failure. So let's look at this. Before we get started, we should define our random variable. So in this case, we are going to let x, our random variable, represent the number of people for whom the drug was effective. So here are the possibilities. If we're testing 10 people, it could be effective for 0 people, 1 person, and so on all the way up to 10 people. Just a quick reminder here, if you are filling this in a table, we can start by, oh, I forgot 0. We'll back up. Start by plugging in a 0 here, a 1, and then rather than writing in all the other values or typing in all the other values, what we can do is highlight the two cells that we have, move your mouse over the little square in the bottom right hand corner, and just pull down until you get to 10. If you don't get far enough, you can keep pulling down and it will keep adding from there. So now we need to figure out the probability that 0 people are going to be successfully treated. 0 out of 10 are going to be successfully treated. We're going to use this formula right here, except we're going to get the spreadsheet to do a lot of work for us. So I'm going to type in an equals sign. There is built into the spreadsheet a function that does combinations, and that function is called combin. It's basically a short form of the combination. We want it to do a combination. We want our number of trials here, n, is equal to 10. So we want to do 10, and in this case we want to choose 0. But rather than typing in 0, I'm going to click on this cell here, which is A7. The reason for that is that when I copy this cell, it's going to automatically move down to the next one, whereas if I just put a 0 in, it's just going to keep that 0 in. So we've got the combination, 10, choose 0. Then we need to multiply, so we use the star for multiplication, by the probability of success. Well, this drug has a 70% chance of being effective, so we're going to multiply by 0.7 to the exponent of the number of successes. So an exponent key is just this little caret, so let's shift 6, and these are the number of successes. So again, I'm just going to click on A7 and it's going to dump that value in there. Then we need to multiply by q, which is the probability of failure. Well, if there's a 70% chance of success, then there has to be a 30% chance of failure. Again, we want the exponent to the number of trials that aren't successes. Well, the number of trials is n minus r. N for us was 10. R is this 0. I'm going to put it in brackets so the whole thing stays as an exponent. So we're going to do 10 minus the number of successes, close off that bracket, hit enter, and you can see there's the probability that this drug is successful, for 0 out of 10 people. It's not very big, as you can see. Again, we can just click on the square in the corner and drag down, and all of a sudden we have the distribution for the entire table, just like that. Now, just a reminder here that all of these are the only possibilities, 0, 1, 2, 3, all the way to 10. There are no other number of people that this drug could be effective for. So this column should sum to 1. And we can see that by typing equals sum, open bracket, and just drag down and hit enter. And you can see that it does, in fact, sum to 1. Now, if we want to calculate the expected value, remember the expected value is the sum of all of the x times the p-x's, p at x's. So, again, in this cell here, type in an equal sign. We want to do the x value, which is A7, times the px, which is right here. Hit enter. 0 times this tiny number is 0. And then we can just drag down, again, by clicking on the square in the corner, drag down, and we get the expected values. Sorry, not the expected values, the x times the p at x's. In order to get the expected value, we want to add up all of the values in this column. So equals the sum of all of the values in this column. And we can see that the expected value is 7. I'm just going to write that underneath so we keep track of what that is so we don't forget. So expected value. Which, if you were to calculate this by hand, you would get the same result. It would just take a little bit longer. Now, if we wanted to graph the distribution, we graph the distribution by selecting the two columns, the x and the probability of x. We can click on Insert Chart. Now, it defaulted to a line chart this time. If that's not what you want, which it isn't, we actually want a bar graph. So we're going to click on this option here for a bar graph. If it doesn't come up as a suggested option, you can just scroll through the list here and find the right one. A lot of the spreadsheet programs call it a column graph rather than a bar graph. In any case, this is the one that we want. And you can see a graph of that distribution. We can clean it up a little bit by changing the title. This title is not very useful, so we might call it probabilities versus the, let me just get rid of this. Call it the probability. So probability versus number of successes. And then you can see the distribution. And again, you can tidy this up a little bit. And instead of having just x, we can call this the number of successes. Fortunately, my screen is small enough that I can't see what I'm writing. So we can just type in here, number of successes. And that's an x value. And here we can, again, talk about probability. Just change that so it says probability. And I think we need to do that just over here maybe. And we'll call that p at x. And again, you can change, the color and the spacing and everything else, and so on. So there it is, using a spreadsheet to create a binomial distribution. We've got the distribution table, we've got the graph for the distribution, and all of that was calculated using the binomial distribution. A lot easier to do it on a spreadsheet than it is to do it by hand.